Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Most Ag2O acts as a mild base nucleophile source and promotes intramolecular rearrangement, ring expansion, via carbocation or neighboring group participation mechanism when a suitable substrate is present. Step 1. Identify the substrate. The starting material is 1-bromomethyl, 1-methylcyclopentane, i.e., a cyclopentane ring bearing both a CH2Br, primary alkyl bromide, and a CH3 group on the same ring carbon, C1. This is a neopentyl type, primary, bromide that cannot easily undergo simple SN2 due to steric crowding at the adjacent quaternary carbon. Step 2. Reaction with Ag2O. Most silver oxide, Ag2O, with moisture acts as AgOH in C2. Ag plus abstracts Br to ionize the C-Br bond, generating a primary carbocation at the exocyclic CH2 plus position adjacent to the quaternary ring carbon. Step 3. 1-2 ring expansion. Wagner-Meerwein shift. The primary carbocation at CH2 plus is very unstable. A 1-2 alkyl shift occurs. One of the C bonds of the cyclopentane ring migrates to the exocyclic carbocation center. This converts the 5-membered ring into a 6-membered ring, simultaneously moving the positive charge onto a tertiary carbon, the former ring carbon that bore the methyl group. This gives a tertiary carbocation on a cyclohexane ring with a methyl group at that carbon, C1 of the new cyclohexane. Step 4. Trapping by O. The tertiary carbocation, 1-methylcyclohexyl cation, is trapped by the hydroxide from most Ag2O AgOH to give 1-methylcyclohexane, 1-ol, a tertiary alcohol. Step 5. Why the other options fail. Option A. Simple SN2 substitution at the primary carbon without rearrangement. This is disfavored because the adjacent quaternary carbon blocks backside attack. Moreover, the ring expansion to a more stable tertiary carbocation is strongly preferred. Option B would require a different kind of rearrangement product inconsistent with the ring expansion pathway. Option D. 2-methylcyclohexane, 1-ol would arise from a secondary carbocation intermediate, which is less stable than the tertiary carbocation formed in the ring expansion, thus it is not the major product. The ring expansion from cyclopentylmethyl to cyclohexyl system, Wagner-Meerwein, giving the tertiary alcohol is the major pathway. Therefore, the correct answer is C. Therefore, the correct answer is option C.